Hi, Bob Fossil here, another video featuring my fossimon debugger program. So I'll be using the medium of Elite's bomb jack and you going through the loader on that and hacking that just to show off some new features in the upcoming version of fossimon. That will be version 005. So first things first, let's see if we can load BombJack. So using my magic Chinese tape adapter. So there's obviously some shenanigans going on there because we've got quite a few line zeros and something brighted out there. But it looks like it's going to load some machine coding and do randomize and call that. So we'll take that at face value. So if we do the clear 987 load dot code. Then we do purely on good faith 65134. Well, that didn't go well, did it? So there's obviously something not quite right in the loader. So let's try that again. I'll just get this tape audio set up properly. There we go. Now, as I can break into it, I could have merged that, but yeah, that would have been easier. So obviously there's something going on here, because say if you normally load the tape, you get a black screen and it loads with those the coloured border, but that went to a white screen and then loaded for about all of 3 seconds before giving up the ghost. So let's pop into the monitor and see if we can figure out what's going on, and we can do that with a new feature I've called user commands. So I've basically added the ability to sort of execute arbitrary bit of code inside the monitor. So there's like a 1K block which you can write sort of like little plug-in helper programs which I call user commands, and these can do specific bits of functionality, and you can also use the functionality of the debugger, so it can read the memory, it can write the memory, it can print to using the sort of the printing routines here. So what I've done is I've written a helper program called list. What that does is that you can trick the list command is where you can trick it by you can embed colors, you can have crazy line numbers, you can have fake numbers, and so there's what you can do is you can read the basic tokens in memory, and then this program tries to sort of output like a deobfuscated listing. And as you can see, we've got the clear 929877, we've got load.code, but then obviously they've used the colors to sort of make to hide out that IncUSR 65465. So that's the actual start address of the program, but if you look at the listing, it looks like it's if we do to the screen there, that first USR command is hidden, so it looks like it's calling 65034, but it's not really. If we do list again, and you can see there's also a rather nice message added by the person who wrote the loader about Prince Purple Rain on compact disc, which is nice. So we know now that the address we really want is 65465. So if we exit out the monitor, do the clear 92877 load code. Go back into the monitor, then we put a breakpoint on, what was it, 65465, and then randomize USR 65465, got a breakpoint. Another thing I've added now is that when you do a breakpoint or a trace command, if you do disassemble without specifying an address, it will now use the program counter address, because you probably want to see a disassemble from where you've broken into. So that seems to be doing a couple of things with values, but then there's a jump to 65206. So another thing I've been working on in this version is improving the trace command. So the trace command now, it pretty much it didn't used to support things where you couldn't, if you had to be push or popped, or you did call or JR or jump, or sort of jumps around in the program. It was, you had to sort of switch back out and then switch back in again, but I've sort of added in quite a bit more functionality in the trace now. So another thing you can do with a trace is you can actually trace up to a value. So we can actually say 65206. So we can actually trace through all that to where that jump occurs. If we do that, we'll get quite a bit of screen output as it actually goes through and traces. At any point this, you can press break and it will break at the point where it's traced up to, but eventually we should get to that trace. So if you would have done that with the old version, you would have been constantly sort of switching in and out rather than doing that sort of being kept in the monitor. So if we do D, so we've got a bit of code there at 65206 which blacks the screen out. That's 16384 is the screen address, and 6911 would be the entire screen, and that's been set to 0 and the LDR. Then we've got a load HL with 65234, which is that load EC down the bottom, and counter for 231 bytes, and looks like it's very simple XOR decryption, because if you carry on disassembling that 65234, yeah, the code's not making a great deal of sense. So what we can do there, if we trace, no, the LDIR, it will have to switch back because it's actually right into memory. Now we're in this decryptor, so what we can do is we can run the trace 65234, trace up to there, but because it's going to execute about 231 times. We don't really want the output. So if you add a minus in after the address you want to trace up to, it will just trace internally, and then it should hopefully break back out when it gets to 65234. So if we now have a look at what we've actually got after the decryption, that's looking a bit more sensible. That's doing disabling the interrupts, moving the stack to the top of memory. IX1638, looks like it's going to load a screen, and then it's going to load a code block, and then it's going to black the screen out. So if we break out of that, put a breakpoint on 65258, because that'll be the point hopefully where it comes back out of that call. That looks like it's blacking the screen again and then jumping to another bit of memory. And that's 65276, that load A 255 set carry flag, that looks like it's doing, that looks like the loading code, because that's, you have to set the carry flag when you do that's the ROM loader, I think. So if we put breakpoint there, 65258, exit that. That's looking a bit more promising. Hasn't bombed out. So I'll just turn the volume down on that slightly because it's a bit loud. I'm going to be able to hear my amazing commentary without that. So yeah, the trace now, I think pretty much, apart from like the sort of odd op codes like the, you know, IM2 and out and in and things and LDIR, most of those will now trace. The user commands, yeah, so that's pretty much finished. It's just there's like a kind of a SDK documentation, so there's all the different bits of functionality you can call. Because as you saw in that one that did the list, that actually printed using like the monitor functionality, and again that's using the monitor functionality to read the basic area. It reads the system variable to get the start basic, and then it sort of reads those bytes and then uses the print functionality. So yeah, I thought that'd be a nice way to sort of, I get requests for like, oh, can I have this command to do this? And I'm thinking, well, I don't particularly want to do that command, or that, yeah, you could do that, but it's going to add a lot of bulk to the program. So yeah, that's my sort of a way around it, and it will also mean I can sort of, if anything starts getting too large in the monitor, I can sort of shift it out to a user command. So yeah, the exclamation mark, that's just nicked from a program I use at work with my C developer called WinDebug. That's like a debugger for Windows and Win32 applications, and that uses an exclamation mark at the start of a command to sort of indicate that it's like a kind of a special external command rather than one of the built-in commands. So, you know, bomb jack on a copy tape. So then obviously this protection being a ROM loader based one, it was quite easy to, I think I did it on somebody did it on a tape to tape for me. So it didn't matter though, because I got a plus D disk interface, so once I'd managed to load it once, I could just sort of snapshot it once it had loaded in. So but yeah, so it wasn't, I think this is also the sort of, I think this one's used on, it's like the Elite loader, it's got, I think Commando uses a similar bit of code, and I think the messages that you see like that one about prints, I think they're sort of quite well known on sort of like Spectrum Easter egg sites in loader messages and things like that, because some of them will got quite involved, and so most of that program when it loads, that basic is that message. So there's not that. There's the bit at the start which is like the multiple lines and like the hidden USR command, but so most of that is just like that sort of bit about the Prince lyrics and about the Purple Rain CD. So I think some of the later ones is a bit disparaging about Elite, I think, because he sort of says, oh, you know, you're a software company, but you're having to get me to write your loaders for your games. So I think we're nearly there, so you only have to put up with me rambling on for a bit longer. It's a nice screen actually. It's pretty decent conversion. It's a shame the music wasn't there, but say this was before I think it might be before the 128K Spectrum was a thing. So that's a good sign. We've broken in. So what we can do first of all is we can use another user command called scr to save the screen. He says, there we go. So that plus at the end of it, that saves the esxDOS plus 3 DOS header, which means you don't have to, you can just do load dot code and you don't have to specify an address. So that's going to blank out the screen and set the border to black. So we can break it that, trace to 6.5. No, that's not going to work, the trace there, because that's going to go out at the on the IR. So I'm just using the extended mode shortcut to do quick trace. That's the screen blacked out. That's the border set to black. Jump to 65521. HL there, DE there. It looks like we're doing a memory move, so it looks like it's moving the code upwards because the destination is 65520, start 64520. So that's going to sort of move from 64520 up to 6 and then go down in memory. Trace that. So that, I would suspect 49483 is going to be the initialization code. I don't know if we're going to get 49483. Yeah, disable interrupt. Yeah, we're doing a bit, and we're setting a stack pointer. That's promising. So if we do 65520, we're using the calculator function in the monitor. 36081. That gives us 29439, so that's going to be our start address. So what we can do now is we do soft reset. That'll get us back to basic with some memory cleared away. So if we do save, bomb C code 29439, comma 36081. So if we think about that, write in some file. Or is that just, oh, did I forget to, oh, that work? Okay, so we've got a screen and our code block. So if I just do a, well, no, I need to do a proper reset because it's still using the soft reset values. So if we just put ourselves a little loader together, 24999, that should give us enough space. Load start bomb dollar. A spoiler alert, we need to set the screen. We need to set the screen to black because of what the game doesn't do. The game assumes that because when the loader was run, that blacked the board and the screen out. We need to sort of do that, and we need to do that twice. So we can do that in a little function at line 100. Actually, we need to do that before we do the loading screen. Load star. Load star bomb.c code. And then randomize USR val. Using val because so that saves the numbers as strings, so it's not, you don't need to do it, but it just means that the basic is a bit shorter. So yeah, clear, go sub, load bomb code, load the screen, load the code, black the screen again, and then start it off. Then 100. Not pi is just a shortened way of doing 0. You don't have to use an actual full number. So that's our little subroutine to close that. So if we do reset that. Load star bomb. Hooray! So we've now liberated BombJack. So it wasn't a particularly hard loader, but as I say, it was a couple of little tricks in there just to keep us on our toes. So the next thing we can do, just as a little cherry on the top of the cake, is we can see if we can do infinite lives for BombJack. So and I know I've shown this in the previous video, but there's another way you can do. I've added in some extra functionality to do another way, which is a bit more interesting. So if we break in there, we save a block of memory with a save memory, and say we save 2500400536. Save that to bomb1. That's basically saving from 25000 to that's to like the top of memory. Do that and let that have a think. Should come back after it's saved. Fingers crossed. There we go. exit that. So we've got 2 lives at the moment under player 1. So we've lost a life. We drop back down, press the enemy. So in version 4 I added a FC file compare, which will let you compare the memory between a file, but I've moved that to a user command now. So what we can do is, if we do user command is fcmp, user commands are all 4 letters, so they can get a bit truncated. But if we do that, the additional parameter you can do with a user command version of this compare is you can actually sort of say the difference that you want. So as we're going down from 2 lives to 1 lives, we'll assume that we're decrementing by 1. So that's basically given us 4 candidate addresses, and the one that looks most promising is that 65395. If we have a look at 65395 in hex, that gives us FF73. So if we have a look for references, if we do use the find, then we do FF73. Got a couple of references to that address, so let's have a disassemble, and we'll disassemble a couple of bytes before that so we get a context of what we're actually doing. So that one at 4532, that was that load 6. That looks like the actual initialization. So if we wanted to sort of give ourselves more lives at start, if we changed potentially, if this is the lives counter, that would be the full. If we poke that with a different number, we could start with more lives. So let's disassemble 49540. Again, that looks like it's loading that with 3. So let's disassemble 49970. So that looks interesting. 49981. We're loading this value in. We decreasing, load it into A, decreasing A, and then loading it back. So that's got all the hallmarks of decrementing the value. So if we poke 49984 and do 0 and then do 49970. So we've knocked out that. So now, so I should have warned that this video contains scenes of me trying to play Bomb Jack. So if I've triggered anybody, I do apologise. It does look like we've got infinite lives. And I'm not doing the bombs in the right order as well, so again, I do apologise. So there we go. So yeah, new features in what I'm calling fossimon version 5.05 alpha 1. So yeah, so code wise it's getting there, but I do need to do a bit more work on the documentation, because the user commands, they've also got example source provided, so you can see how the user commands are written, and you can then hopefully write your own commands and have a play about with that. So yeah, hoping to have well, at least alpha's out at the usual place on the Spectrum Computing Forum post for fossimon. Probably next week, so that's going to be into October at the time of doing this video. So yeah, tracing, fast tracing improvements and user commands. So that's, yeah, I say, yeah, quite a lot behind the scenes. So especially the tracing, that was a bit of a to get working. But so if you've got opcodes that still sort of reference memory, those aren't read. But it's just that I just didn't get around. I know how to do it. It's just I thought I'd put enough into the tracing. I thought I'd better sort of make sure that was working okay before I started adding in extra stuff. I'm not sure whether it's fully R register compliant. I'm emulating the R register, so that's the refresh register, which gets updated every time you execute a Z80 opcode. So my tracing code looks like it's doing the right thing, but as I say, whether you could actually trace through any code that uses like an R register decryptor, like a commercial protection system like Alcatraz or Speedlock, I've not tried that, so that might be a future video, or maybe not, I don't know. Anyway, thanks for watching and getting this far. So I see you when I do the next video. Take care, bye.